Today, I'm going to be talking about hydrothermal vents. First of all, what is a hydrothermal vent? These are natural hot springs, or vents, pouring mineral-rich water from beneath the seafloor. We've only known about them since 1977, so we're still learning about the kinds of life they support and the functions they have for the ocean. Hydrothermal vents form when seawater trickles down through breaks in the crust of oceanic plates, near what are called subduction zones, which form when two tectonic plates move either away or towards one another. These are often volcanically active areas, with magma welling up and remaining close to the crust underneath the seafloor. After the water seeps down, the magma underneath the crust heats it and drives reactions that remove chemicals like sulfates, magnesium, and oxygen from it. Then picks up metals like iron, zinc, copper, cobalt, and lead from the hidden rocks and reemerges through the vents. The water can reach temperatures over 700 degrees Fahrenheit, but won't boil because of the incredible crushing pressure on the ocean floor. The vent water is full of important minerals carried up from underneath the earth. As the minerals move from the super hot inside of the earth to the cooler seawater, they solidify, and many of the minerals and metals picked up begin to precipitate, forming what are called chimneys. Chimneys formed from deposits of iron sulfide appear black, while chimneys formed from deposits of barium, calcium, and silicon are white. Water coming out of the vents has an incredibly low pH, is filled with heavy metals and toxic chemicals, and is boiling hot. This combination should be deadly, and it is to most marine life. But despite the inhospitable conditions, some bacteria have still managed to flourish by developing unique biochemical mechanisms to cope with the conditions that we would find highly toxic. Because there's no light at the bottom of the ocean, photosynthesis cannot occur, and so we might think that this would constrain the autotrophic life there. But these bacteria, rather than using the traditional pathway of photosynthesis, use chemosynthesis. They use the hydrogen sulfide from the vents and oxidize it, converting it to sulfur. The energy released during this process is then used to combine carbon, hydrogen, and oxygen into sugars. This is known as chemosynthesis. As producers, these bacteria form the basis of an entire ecosystem supported by the vents. They are consumed by snails, clams, and mussels, which are then consumed by shrimp and small crabs. Those, in turn, are eaten by octopi, fish, and bigger crabs. Hydrothermal vents are important in that they transport heat and chemicals from inside of the earth to the outside, regulating global ocean chemistry. The life forms that are supported by these vents are unique. We don't know a lot about them, but learning more can help us in many ways.